Hi, this is Rhett. I am a fourth year. This is part one of an introduction to electrocardiograms. It's probably going to be a couple videos, but I'm still, as many videos as it is, I'm trying to give you a really basic overview of electrocardiograms and how the things you should know about, at least going into the wards. So just a little bit of trivia. Most people, I think it's common for people to refer to electrocardiograms as EKGs, but they're actually, I think it's becoming more common to call them ECGs, cardio with a C in English. Just some trivia, EKGs, the K comes from the original Greek, where cardio with a K meant heart. But I definitely know some attendings who get irritated when you call them EKGs, so I would recommend calling them ECGs to be safe. So just an overview of the overview. ECGs are really non-invasive and fast tests. They can provide a lot of information about cardiac function. Some of the things they can tell you about is the rate and regularity of heartbeats, how big the chambers are, and probably most clinically important is if the heart has any signs of damage. It's not a 100% accurate test. I can't tell you everything, but it can definitely give you a lot of clues and point you in the good direction. So it's good to know about them when you're on the floors. All right, so getting started. Let me fix my colors here. Okay, so most of you should know that ECGs are often printed on graph paper. The graph is separated. The y-axis right here. I'm looking at squares. Sorry about that. Okay, this is amplitude, which I'm not working on now. All right, so this is amplitude. That's in units of millivolts. Each big square is going to be, I know this is bad, 0.5 millivolts. I should have it after the number, but you get the idea. This line down here, this is time, and its big square is equal to 0.2 seconds. The small squares will be 0.1 millivolt, 0.1 millivolt, and the time is 0.04 seconds. Just you know that 1 millivolt is equal to 1 millimeter on these graphs, so that's a good idea of what's going on. You can always say, like, if you need a 2 millimeter, say, for example, a Q wave, you need a 2 millimeter change in amplitude. You can also say a 2 millivolt change in amplitude. All right, and then this graph paper is going to be usually divided. If it's a standard 12 lead ECG, it's going to look something like what we have over here. These leads are most often organized in the following way. With the limb leads over here, this would be 1, limb lead 2, limb lead 3, and these are the AVR, AVL, and AVF leads. So right over here are the limb leads, and over here are going to be the precordial leads. This is V1, V2, V3, V4, V5, and V6. And usually down here you'll have a longer strip of several of the leads that are above here. Often it's going to be limb lead 2, it could be 1, it could be F. Those change, but usually 2 is down here. And so that's it for this video. In the next video we'll talk about electrode placement and how we make leads. Thank you very much.